Hello everyone, I'm Julia, and today I would like to explain to you guys how you can find the theta or the degrees in a right triangle when you just know the two lengths in the right triangle. So here is Julia, and David here is chasing after Julia, and they are apart, let's say 43 miles. And then Julia here decides to climb up this mountain, which is just straight up, and so that makes it's a right angle, 90 degrees. And so Julia is now at the top of this mountain, and David wants to get to Julia, and so he decides that he can't just catch her in time, and so he decides that he's going to use his cannonball to launch himself up there. So here's his cannonball, and so now he needs to figure out what degrees his cannonball has to be in so he lands like right next to Julia, who is at the top of the mountain. And here's David. So, and the height of the mountain is 38 miles. And we're trying to find what degrees it is. And so before I get into it, I'd like to remind you guys that you're gonna have to know the values of the trig functions. So for the sine theta, we would have the opposite over the hypotenuse, and for the cosine theta, we would have the adjacent over the hypotenuse, and for the tangent theta, we would have the opposite over the adjacent. And so we're going to have to use one of these to solve for the theta here. Now to find out which one we're going to have to use is by looking at which values we have. So in this triangle here, this side is the opposite and this bottom is the adjacent, and so we only know the value of the opposite and the adjacent, and the trig function with the opposite and the adjacent, both of them, is the tangent theta, and so we're going to be using this equation here. So if we have tangent theta and we put in the values of the opposite and the adjacent into this fraction, we would have 38 over 43. And then if we switch these two values here, we would get tangent, the inverse of the tangent and of 38 over 43 equals theta. And so since we switched these two, the fraction and the theta, we got the inverse theta of the fraction. So now if you just put this into your calculator, that would get you the degrees. And now I would like to provide you guys with another example. So here we have a person at this top of a mountain with a binocular, and 29 miles away from this person with the binoculars, there there is a turtle swimming around in the sea. So this mountain is right next to the ocean, and this turtle is just swimming around the water, and this person is 35 miles above the water, since he's at the top of the mountain, and so this person thinks that he saw something in the ocean, and so he grabs his binocular to look in the direction of the sea turtle to see what he saw. And so now he's going to have to figure out in what angle he needs to have his binoculars faced in the direction to be able to see what he saw, which are the turtles. So this is the degrees, or the theta. So using this, how can we find the degrees here? Well, actually, let's say that we also know this length here, which is 52 miles. And so we know, I'll just write the trig functions again on the top, so opposite of the hypotenuse. Cosine theta is adjacent over the hypotenuse, and the tangent theta is equal to the opposite over the adjacent. And so we cannot really use any of these three functions, the trig functions, to find the degrees here, since we know all of these three lengths of the triangle. And so I'll just try it with the cosine theta, even though we can use any of these. So cosine theta is equal to the adjacent over the hypotenuse, and so if we put in the values for the adjacent and the hypotenuse, we would get 35 miles over 52 miles, since this side is the adjacent and this side is the longest side is the hypotenuse, and so we would get that. And if we switch these to the fraction and the theta places, so then we would get the inverse of the cosine of 35 over 52 equals the theta. And then if you just put this into your calculator, you would get your degrees, your answer. So now I would actually like to do one more example. So now it's not really going to be a story. I'm just going to do a random triangle, right triangle. So here we have a right triangle, and we know, and this is the theta we're going to be working with. And if we know the value of the opposite here, which is, let's say, 14, and the value of the adjacent here, let's say that we know the value of the hypotenuse, which is 7, or is 3, then what we would need to use is the sine theta, since the sine theta is the opposite of the hypotenuse. And so then we would get sine theta is equal to 14 over 3, since that's the opposite over the hypotenuse. And then if we switch these two, the fraction and the theta, we would get the inverse of sine, parentheses, 14 over 3 equals the theta. So all you would need to do is put this into your calculator to find the degrees. So in this video, I provided you guys with 3 examples for how you can find the degrees in a right triangle with only knowing 2 or more of the values of the 2 or more sides of the right triangle. So I hope you guys enjoyed watching this video. Thank you for watching. Bye.